design of high precision sensor system for the optomechanical application. This is the abstract and its mechanical mode, picture, and its mechanism, how it is working, and everything is defined in this document, methodology, and equations used in the MATLAB code. So let me just show you. This is the MATLAB Simonic model for the sensor, MEMS accelerometer sensor. Yes, this one. Okay, so this is the MATLAB code for the MATLAB Simonic model for the accelerometer. Let me just run this first model. This is a Simonic model. Simonic model will be run in few minutes. It will take some time, and this is basically its MATLAB code. We will run the MATLAB code after the MATLAB Simonic model, but let's first and this one is also constants.m file, which contains the constant of the high precision cavity optomechanical displacement based sensor. Its output is torque, and the voltage and the force will be displayed in this section. But let's wait to finalize the model first. This is basically the MEMS accelerometer mechanics. Here we can start the simulation, but first of all we need to wait for the running of Simulink model. Basically, these are the constants that are used in this model. But, hmm, is a novelty. It is added in the system. Let's wait for this first. I think yes. Yes, this is the output graph for the force, voltage, and the torque for this Simulink model. And next part is this is called our main design. We just run this model first. Yes, it means that the pebble is rolling accordingly, and that's calibration magnetometer data is here. Okay. The circle will complete according to the pebble rolling, like these lines filled by the circle. Then the simulation will be completed. This is basically an uncalibrated magnetometer data based on the magnetic field with the time. And this is the calibration of pebble rolling. How the pebble is rolling and the magnetometer data will display according to this graph. Yes, pebble circle is completed and this is a calibrated complete. Calibration is completed. Okay. So this graph is displaying the accurate measurement of calibration. This graph is basically torque magnetometer sensor, force detection sensor according to frequency, noise level comparison, sensitivity comparison, and the accelerometer frequency response. So, yes, in this section, it displays the calibrated time completed in 3.54 seconds, and its center will be this. Okay. according to the residue and radius. Okay, I think this is a completed video for the